Hello everybody. In this tutorial I will show you how to excavate through a soft clay layer to build a foundation on the underlying stiff clay. The topics that I will cover in this video are staging in the water table, excavations, and also I'm gonna explain how to set a reference stage. A reference stage, what I mean by reference stage is to show the settlements in each stage separately, and we will show and we will see this how we can do this together in Settle 3D. So the first step is go to Analysis, Project Settings. I'm gonna keep everything as a default. I'm not gonna add time-dependent consolidation analysis in this video. So in general, keep everything as it is. The method of stress calculation is Bosinisk. The units in stress kilopascal and settlements millimeters. We're gonna add 4 stages. So I went to stage tab. I'm gonna add 4 stages. The first stage I'm gonna call it stage 1. The second stage I'm gonna call it water table drop. So here in this video we have different table. I will show you how to add this in Settle 3D. The stage 3 I'm gonna name it Excavation. Stage 4 load. So after we excavate, we're gonna load the excavation. So the first stage is nothing, just block of soil. Second stage, we're gonna change the water table 2 meters below the ground surface. Then we're gonna excavate, and then we're gonna load that area that we excavated. I'm gonna show you how we can calculate the settlements at each different stage. Okay, go to the groundwater table tab, click on groundwater analysis, activate this option, keep the unit weight of water as it is, as a default 9.81 kilonewton per cubic meter, and I'm gonna activate the depth varies with stages. In the first stage, the depth of water table is 0, which means the water table at the ground surface. Then in the second stage it's gonna drop 2 meters below the ground surface. The sign here conventional is positive, which means below the ground surface. In Settle 3D, positive means below the ground surface. And the third stage, we gotta keep the water table in 2 meters, and the load stage also 2 meters for the depth of water table. So after we finish that, we click on OK. Now we should have actually 4 stages in the bottom left screen. At the bottom, the left bottom of the screen, we have 4 stages. The next step now is to define or to add the excavation on the third stage. So we make sure we are in the third stage, and we go to loads and then add excavations. You need to read this carefully because here it says the actual 3-dimensional stress, displacement, and groundwater pore water pressure distribution due to excavation is not computed. Okay, so click on OK, and now he's asking about the coordinates of our model. You can define the coordinates manually or graphically by using the mouse, or you can enter them in this line here. So the first point is going to be 0 and 0, enter. Then 10 for x-axis and 0 for y-axis. The third point is 10 for x and 20 for y. The fourth one is 0, 20, and then we click on or type C and enter to close the model. We have this window. He's asking about the depth of water table. The default is 10 meters. I'm gonna change it to 2, and make sure Oh, sorry, he's asking about the depth of excavation, not the water table. So the depth of excavation, because we already add the excavation from the loads, so the depth of excavation is 2 meters, and we make sure that the installation stage on excavation. Okay, and then we're gonna add load on the loading stage. So we change this installation stage to load, and we're gonna add 40 kilopascal in this stage. So we have excavation, then we're gonna load that area with 40 kilopascal. The excavation is gonna be in the excavation stage, which is the 3rd stage, and then the loading is gonna be in the 4th stage, the final one, which I call it load stage. Okay, we click on OK to exit this dialog. Oh, nice, we have our model. We are in the stage 3. Let's go back to stage 1. We have nothing here, which is what we expect. We didn't assign anything here. And the 2nd stage, as you can see, this blue line represents the water table. We have drop 2 meters below the ground surface. So you can see in the 1st stage, the water table is at the ground surface. That's good. This is what we assign it to the model. On the 2nd stage, the water dropped 2 meters below the ground surface, and then we have the 3rd stage, which is the excavation. Now we can see the material that we removed here, 2 meters, and the 4th stage we add the load, which is 40 kilopascal. Okay, you can edit actually by click on edit if you want to change the properties of the excavation. Okay, now let's define our engineering properties for the soil. The default in Saturn 3D is always like 20 meters below the ground surface, so we have one soil layer here. The depth of this layer is, or the thickness of this layer is 20 meters, and the bedrock is always assumed at the bottom of this layer. Okay, we're gonna change this to 2 different layers. So first we're gonna define the engineering properties for this materials, and then we're gonna assign it to our models, and then we can modify the thickness of each layer. So go to properties and then choose soil properties. Let's change the name of the first layer to soft clay. You can change the colors if you like. I'm gonna keep them as default for now, and then I'm gonna change the, actually let's keep it, or no, let's change the unit weight to 16 kilonewton per cubic meter, and the saturated unit weight is 18. So we have 2 unit weight and 16, and the saturated one is 18. The Poisson ratio, I'm gonna keep it as a 0.2. I'm not gonna activate the immediate settlement. I'm gonna go to primary consolidation. I'm gonna also define C sub C 1.2, C sub R 0.2, and the initial void ratio is 1.6 for this model. The over consolidation ratio, I'm gonna keep it as 1. And if you don't have these parameters, you didn't conduct any lab testing, you can obtain them from here. You have like long lists of C sub C here, and since we define this as a clay, soft clay, we can choose from the list clay, and then we can pick any value. The software give you different value for different type of materials. You can pick any value from here which correspond to the soil that you have in the field. So this is for our first layer. The second layer, I'm gonna name it as stiff clay. Okay, I'm gonna keep the unit weight as it is, 18. Then I'm gonna go to C sub C. Actually, let's keep everything as it is. I'm not gonna change anything for this layer. Okay, so click on OK. to exit this dialog. So now we already defined our engineering properties for the materials, but we haven't assigned any of these materials to our models. To do that, you go to properties, soil layer, and then the default is like assign the first layer 20 meters for our first material. We're gonna add another layer below this layer. So you see here we have soft layer and stiff clay. You can change them, of course. I'm gonna assign the soft layer and the first layer with thickness 2 meters below the ground surface. The stiff clay, it's gonna be 15 meters below the ground surface. So now we have two layers. The first one is 2 meters, and the thickness of the first layer is 2 meters, and the thickness of the second layer is 15 meters. The bedrock is always assumed at the bottom of the last layer, or this layer. So the bedrock will be 17 meters below the ground surface. Click on OK. We have our models. We are on stage number 4. That's why we see everything here. Okay, now we need to assign point grid. So we go to grid, auto field point grid, or you can click on Ctrl A to get this window. I'm gonna change the number of grid points to 500 instead of 300, and I'm gonna keep the expansion factor as 2. Then click on OK. So a grid will be generated, and stress and settlement will be automatically computed throughout the 3-dimensional volume. By default, contour for total settlement, as you can see here, will be shown. Your model for stage 1 should look like this. There is nothing at all. There is no settlements. As you can see, the maximum settlement in the stage number 1 is 0, because we just have block of soil. We don't have load. We didn't excavate. We didn't do nothing here. Okay, so you should have 0. Okay, so let's go on stage number 2. Remember what we did in stage number 2. We decreased the depth of water 2 meters below the ground surface. Okay, let's see the deformation, how it looks like. So we have maximum settlements about 480 millimeters, and it's changing. Of course, it's is maximum at the top of settlement and decreasing as we go down. So what's happening here? What happened? This has happened because the dropping of water table caused a drop in bore water pressure, and therefore an increase in excess stress. Okay, the increase in excess stress caused a significant amount of settlements. That's why we see a huge amount of settlements. It's about like about 50 centimeters. Okay, so now let's go to the stage number 3, which is the excavation, and see what's happening here. So you see there is no contour lines in the excavated area, and that makes sense because we don't have soil here. Okay, but if we go just below that excavation area, now we see contour lines. Okay, so in the just on the top of that, of the excavation, you will not see any contours in the area that has been excavated, because we are looking at the surface and there is no soil there. Okay, in the depth box on the right hand here, scroll down through the soil by increasing the depth, either by changing the number in the depth box or by clicking and dragging on the soil profile. At depth like let's say 2.3 or 2.1, just below the excavation, the total settlement should look like this. Okay, the maximum settlements in all stages 500, but in this stage is 480. Okay, you can see that there is a bob out if we go and activate the deformed contours. You see here this pop up. This is because of the uplift. When we check the soil, there is uplift here, and you can see it clearly. The plot actually looks odd because the large downward settlements in stage 2 caused by water table drop. To see the displacement actually caused by the excavation only, we can see the stage number 2. We can set stage number 2 as a reference. So this is actually from the contours that we're seeing here is from all stages until number 3. But I'm interested to see only the deformation in this stage, which is excavation. To do that, we need to set the previous stage as a reference. To do this, actually, it's very easy. Just right click on the previous stage and choose set as reference stage, and then go back to excavation, and now we see the settlements due to excavations only. Okay. So let's go to the next stage, which is load, and see how the settlements look like here. We have settlements due to the applied load. This is clearly here. It's about 25 millimeters positive. Okay. Now let's plot the data and see how they look like. To do that, you need to assign point query, add query point to the middle. I'm gonna add it to the middle of the excavation. So just click on it. You can see the settlements, total settlements on this stage, as well on this stage. Then right click on the point that we just added and choose graph query. You can choose just specific stage, or you can see all the stages together by selecting all the stages. And then I'm gonna reference the stage as a default to see all data. You can see here that the maximum settlements occurred due to the water table, which is about like 500 millimeters. And the first stage there is no settlement, which makes sense. And we have also about 300 to 170 millimeters due to the load, and then we have this blue curve due to the excavations. Okay, now I'm just gonna show you how to present the data, or to show the settlements due to a water drop. So I'm gonna go back to this point, right click, graph query. So I'm gonna choose the last two stages, and what I'm gonna change here, I'm gonna change it to water table drop. Keep this stage as a reference to show the settlements for water table drop. Let's see how the data look like. You see now it's completely different. So it's now clearly show how the excavation causes 150 or 160 millimeters of uplift, because minus the uplift up. Okay, and Satur 3D positives downward, negative upward. So you can see that the excavation caused about 150 uplift, and subsequent load produce a settlement of 70 millimeters of the settlements. So you can repeat the same thing, repeat the above step actually settings in the excavation stage as a reference, and and you will see that the settlements due to the applied load alone is like, let's see this together how we can do that. Just right click on it, query, and let's keep the excavation as a reference. Okay, and let's see how the settlements look like due to for these two stages. Okay, so this is the settlements, how they look like if we set the excavation as a reference. This settlement, which is in the green line, shows the settlements due to the loading only, because we set this stage, which is the excavation, as a reference. Now we are showing the settlements due to the load only. Okay, thank you so much for watching, and I hope you like this video. Please subscribe and share to my channel. Thank you so much.